Riemann sums, classwork part 4. Now let's try one. Let f of x equal x squared minus 3. We want to find the area of the curve using 8 rectangles / trapezoids from x equals 2 to x equals 6. First, let's draw it. Note that the curve is completely above the axis. If it dips below, the method changes slightly. So this is a picture using a graphing calculator. The drawing of the curve is helpful but not necessary. Since there are 8 rectangles, we are finding the area between x equals 2 and x equals 6. The base is, and remember that this is the width, and we find it by finding delta x. So delta x is going to be the upper number, which is 6. That is the highest x coordinate. And the lower number, 2, 6 minus 2, and dividing by the number of rectangles, and we get 4 over 8, which equals 1/2. So our delta x, or our base, is going to be 1/2. Next, we're going to complete the chart. So, our first rectangle, we're going to substitute in 2 for x into our formula. So we put 2 right here. We square it, we get 4 minus 3, and it's going to equal 1. Then we're going to go to the next rectangle, and we're going to increase by 1/2. So we're going to get 2.5, or 2.5. And we put that into our equation, and we square and subtract 3 from it, and we're going to get 3.25. 2.5 squared is going to be 6.25, and then minus 3. The next rectangle is going to be a 1/2 added to that. It's going to equal 3. So we're going to square that and get 9 minus 3, and we get 6. Next, we're going to use 3.5. And we're going to square 3.5 and subtract 3, and we're going to get 9.25. And we could add zeros on the end of this. It would be fine. And then we're going to put 4 in. And so we get 16 minus 3 is 13. Then we're going to put in 4.5. We're going to square that and subtract 3. And we'll get 17.25. It's probably going to be easiest if you just put the equation from here into your y equals, and then just go to your table and you can put the numbers in. Our sixth rectangle number is going to be when we put 5 in, and we get 22. And then we're going to put in 5.5. And we're going to get 27.25. And then we're going to put in 6. And so that's going to be 33. Now, the numbers in the chart, these are our rectangle width, or not our widths, but our x coordinates. We're not going to use this in our area. We're going to use the y coordinates that we get right here. This is going to be our base, or our width out front. This is going to be the values of x. So when we do right rectangles, what we're going to be doing is, remember that we want 8 rectangles. So there's 1, 2, 3, 4, 5, 6, 7, 8. So using the right ones, we're going to be doing the 3.25 and below. We don't use the very first one on the right rectangles. When we do the left rectangles, we start with the first one, we go all the way to the next to last one. So let's write that out. So our area formula then for our right rectangles, we're going to have A equals, and then it's going to be our 1/2 out front. Then we're going to have 3.25 plus 6 plus 9.25 plus 13 plus 17.25 plus 22 plus 27.25 plus 33. It's pretty sloppy. So we'll say the area for our right rectangles, and I'm going to use an R here, is going to be equal to 65.5. and that's if we add all those together and then multiply by our 1/2. Now, doing the left ones, we're going to get our A equals, it's still going to be a width of 1/2, but now we're going to start with our 1, and then we'll have 3.25, and then plus 6, plus 9.25, plus 13, plus 17.25, plus 22, plus 27.25, and we stop there. And so the area using the left rectangle, that's the left-ended side, then we would get 49.5. Now for the trapezoid, our area, it's going to be, the area of a trapezoid is always going to have a 1/2, and then it's going to be multiplied times our width, or our height. So it's going to be another 1/2. And then, remember on the trapezoid, we use all of the numbers, but we use the first one as a 1 times that, and we use 1 times the last one, and then we use 2 times all the rest of them. So we're going to have 1 times 1 plus 2 times our 3.25 plus 2 times our 6 plus 2 times our 9.25 plus 2 times our 13 plus 2 times our 17.25 plus 2 times our 22 plus 2 times our 27.25 plus 1 times our 33. And then when we do that calculation, and this is for trapezoids, our answer is going to give us 57.5. Now notice that's between the other two numbers, and it should be because it's going to be a more accurate estimate. Now for the midpoints, what we have to do is average. So we're going to average each of these together along the way. So you're going to add those two and divide by 2, then add the next 2 and divide by 2, and you have to do that in succession there. And so if we go through and do that, we're going to come up with our area is going to be equal to 1/2, and then that's our width. And then our first one, when we get our average, we're going to get 2.125, and then our second one's going to be 4.625, and then our next one will be 7.625, and the next one will be 11.125, and the next one will be 15.125, plus the next one will be 19.625, plus the next one, which is 24.625, plus one more rectangle, and it's 30.125. Now if we calculate that whole thing, put that together, we will get, and I get for the area using the midpoints to be 57.5. And notice that that's really close to the trapezoid. Midpoints and trapezoid are probably the best approximation, but they're more complicated. This is the end of part 4.